All right, today we're doing probability of compound events. You need to know a compound event is made up of two or more simple events. If the outcome of one event does not affect the outcome of the other event, they're called independent events. They don't affect each other. When you're figuring the probability of independent events, you take the probability of A times the probability of B occurring, and that's your answer. All right? Any questions? All right, this is a bag contains 6 black marbles, 9 blue, 4 yellow, and 2 green. It's a marble is selected, replaced, and then a second marble is selected, which means they're independent events because the probability of selecting the first marble does not affect the probability of the second marble because you throw that marble back in there. So it doesn't affect it. That's why it's called independent. Find the probability of selecting a black marble and then a yellow. So what we do is we find the probability of a black one. So how many black are in this bag? 6. How many total marbles are in this bag? 21. Okay, 21. Then we find, so that's the first marble. The odds of finding a black marble are 6 and 21. What's the odds of finding the second marble? What color do we need for the second marble? Yellow. How many yellows in the bag? 4 out of how many total marbles? 21. Okay. So to find the probability of a black and then a yellow, we multiply these. Which gives me 24 over 441, which you can leave that as your answer, or you can divide it and change it to a percentage, and it gives you 5.4%. So the odds of grabbing a black one and then a yellow in that order is just over 5% of a chance. Is that a high percent chance? No.
Can you
All right, so it's asking to find the probability of a blue one and then a green one, but they're independent, meaning they don't affect each other. So what's the odds of finding a blue one? How many blue was in the bag? 9 out of how many? 21. What's the odds of finding the green one? 2 out of 21, right? So we multiply that, you get 18 over 441, which if you want to leave that as an answer, that's fine. It's equal to 4.1%. So not even the 5% chance of this occurring. Now let's do probability of not drawing a black and then drawing a blue. How many black was in the bag? 6. So how many are not black? 15. How many are blue? 9 out of 21, right? So you multiply those, you get 135 over 441, which is a 30.6% chance of occurring. This says if the outcome of one event affects another event, they're called dependent events because they affect each other. Probability of dependent events, to calculate it, you find the probability of A, and then you find the probability of B after A. So it's like if you didn't replace that marble after the first marble, you didn't put it back, that's going to affect how many are in the bag. Instead of 21 marbles in the bag, how many would be in the bag? 20. So could you draw that same marble twice? No, because you didn't put it back. That's why they're called dependent events. They affect each other. All right, so write this down. All right, it says Henry randomly draws 3 cards at one time without replacement. You're going to find the probability that the cards are drawn in this order, which is diamond, spade, diamond. So what we do is we figure out what's the probability of drawing a diamond. How many diamonds is in a deck of cards? Does anyone know? Someone said it. 13. There are 13. Okay, there are 4 suits, diamond, spade, club, and hearts, right? So, and how many cards are in a deck of cards, do you know?
52.
52. So 52 divided by 4 would be 13. So the odds of drawing a diamond are 13 out of 52. Now, what's the odds of drawing a spade? Okay, how many spades would be in this deck of cards? 13. How many cards are in this deck of cards? 51. You've already drawn a diamond out. we're assuming that you got what you wanted, the first card. We're assuming you got a diamond. So there's 13 out of 52 cards in there, and then there's 13 out of 13 spades, but there's only 51 cards. Now, what's the odds of drawing a diamond again? How many diamonds are in this deck of cards? 12. And how many total cards are in there? 50. All right. So we multiply those. Okay. You get this. 13 over 850. They reduced 12 and 50. And which that comes out to a 1.5% chance. They reduced the 13 over 52 to 1/4, and they reduced it to 12 to 6/25. All right, and then they multiplied those, and they reduced it as far as possible, 13 over 50. All right, so you're supposed to find the probability of drawing a 4, and then not a jack. So what's the odds of drawing a 4? How many 4s are in a deck of cards? 4. There are 4 of them out of 52 cards. What's the odds of drawing another 4 out of that deck of cards? 3 out of how many cards? 51. And then what's the odds of drawing a jack? How many jacks are in deck of cards? 4. So how many would be left if you're not drawing a jack? 46. Remember, there's 50 cards in this deck. Right? 46 of them are not jacks. So you can reduce those, multiply those out. You get this. 23 over 5.525. That's what it reduces to. Which comes out to 0.4% chance. The odds of drawing a 4, and not a jack are a less than 1% chance. Any questions? Write this down. Events that cannot occur at the same time are called mutually exclusive events. When we're finding the probability of a mutually exclusive event, meaning they can't happen at the same time, like rolling a dice, you can't get a 3 or a 5 at the same time, we add the probability. So we have the sum of the probability. So write this down. The dice is being rolled, we need to find the probability of rolling a 3 or a 5. So what's the chance of rolling a 3? How many 3s are on a dice? 1. Okay. How many sides are there? 6. So the odds of throwing a 3 are 1 in 6. What's the odds of rolling 5? 1 out of 6. So what we do is we add those. Okay. So you get 2/3, which is the same thing as 1/3. So you got a 1 in 3 chance of rolling a 3 or a 5. Alright, so we need to figure out the probability of drawing at least a 4, rolling at least a 4. So a 4 is a 1 in 6 chance, a 5 would be a 1 in 6 chance, and a 6 would be a 1 in 6 chance. So we add those, you get 3 out of 6, which is half, so 50% chance of rolling at least a 4. For events that are not mutually exclusive, meaning they can occur at the same time, we add the probability of A and the probability of B, and then we subtract the probability of them both occurring at the same time. So write this down. Alright, so of 240 girls, 176 are on the honor roll, 48 play sports, and 36 do both. They're on the honor roll and play sports. What's the probability that a randomly selected student plays sports or is on the honor roll? So, what's the probability of a girl that plays sports? How many play sports? 48 out of how many? 240. What's the odds of being on the honor roll? 176 out of 240. What we do is we add those, but then we subtract the chance that they're on both. How many are both? 36 out of 240. Because how can you select someone twice? Right, you can't. So that's why you got to subtract those. So 48 plus 176 minus 36 gives you 188 out of 240, which reduces the 47 out of 60, which is a 78% chance of occurring. Here's your assignment.